Alright, hi, in this video we'll be talking about trig identities and derivatives of trig. If you already know the derivatives of trig and I just want to see the practice problems, you can skip forward to where I do the remaining practice problems from the previous video. But other than that, let's start with trig. So Pythagorean identities, these you should know already from pre-calc. Same with double angle formulas. If you don't, you should go online, find a sheet and try to memorize it. This one will be used a lot. This one will be used a lot. In fact, I saw this one on the AP exam when I took it. This one is not so much, but just know all three of them. And for double angle formulas, our teacher told us that we need to know all of these. For AB and for BC, you need to know half angle formulas. But the only ones that I really use is this one. This one's important, sine 2 theta. And cosine 2 theta is the only one we really used is this one. For the other ones, we never really used in calculus. In fact, all the College Board and past practice problems I've done, I don't think I ever came across these ones, but again, it's just good to know. So try to memorize all of these, but prioritize these two. Alright, now that we got those covered, let's talk about the derivatives of trigs. So first we have derivative of sine x. That's a very bad sine x. Sine x. And that is equal to cosine x. Next we have derivative of cosine x is equal to negative sine x. Okay, these are really, really important, so you really need to memorize these, and there's not really an easy way to do it. You just know that derivative of sine x is cosine, and derivative of cosine is negative sine. And then we get to the little bit more complicated parts, where we have derivative of tangent x, tangent theta, tangent x, same thing, is equal to secant squared x. Secant squared x. And if you do not know already, what you really should is 1 over cosine is secant, and 1 over sine is cosecant. It's like, okay, the first letters are just swapped. So just know that 1 over cosine is secant, 1 over sine is cosecant. Okay, now we'll get here, and if you want to prove how this works, we'll be using quotient rule, which we did before. So if you're asked what's the derivative of 10x and you forgot that secant x squared, which you should not forget because you'll be dealing with it so much, here's a proof for it. So 10x is sine x over cosine x. And so when we use quotient rule, when we find the derivative, that is derivative of the top, which is cosine x, times cosine x, minus the normal of the top, times the derivative of the bottom, which is negative cosine x, negative sine x, sorry, negative sine x. And these two negatives make this become a positive, make this become positive, and make this become positive. And if you see here, okay, and then on the bottom we have cosine x squared. And then so on the top will be cosine x squared, cosine squared x, sorry, plus sine squared x over over cosine squared x, cosine x squared. And in our identities, we know that sine squared x plus cosine squared x is equal to 1. So this entire thing on top is 1. So 1 over cosine x squared is just secant x squared. Okay, so yeah, that's a proof for those. Okay, next we have the derivative of, what is the next? Secant? Okay, give me a second. No, let's first start with cotangent, because cotangent matches with tangent. So cotangent is just cosine over sine, and derivative of cotangent x is just equal to the opposite of this, which is a negative, and negative, instead of secant this time, it's cosecant. Cosecant squared x. So if you can see here, sine x is equal to cosine x, and the derivative of cosine x is equal to the negative of the sine x. And then derivative of tan x is equal to secant squared x, and derivative of cotan x is equal to the negative of cosecant squared x. So you should be able to see, you should start seeing a pattern here. And then the last two, which is derivative of cosecant x, and that will be, no, let's start with secant x, because cosecant x is just, you can use a pattern for that. So let's start with secant x. Derivative of secant x is equal to secant x, oh my god, my pen's lagging, secant x times tan x, tangent x. And then derivative, if you can try to pause the video and figure out the derivative of cosecant, it's just going to be very similar to the top what we did. So derivative of cosecant will be equal to the negative sign, and then it's going to be cosecant x times cotangent x. Again, all of these can be easily found on Google, so make sure the first thing you do is to memorize these before you deal with any trig in your class, because these are very important. Okay, now that we have all those written down, let's go over here and start working on where we left off from yesterday. Number 9, we have secant 2x to the 4th power. This should be in parentheses. Oops, parentheses. Okay, now we treat the 2x fourth like g of x. So our g of x will be 2x fourth, and we take f of x, which is secant x, with respect to g of x. So we learned earlier that secant x is sec x cosine x, secant x tan x. So it'll be secant x tan x. But we're taking it with respect to g of x. So instead of writing x, we'll be writing 2x fourth. And same with here, 2x fourth. Okay, now we took the derivative outside of fx with respect to g of x. Now we take the derivative of g of x, which is 2x fourth, and since it's a chain rule, we need to multiply this, times derivative of 2x fourth is, we use power rule, bring the 4 down, 2 times 4, 8x cubed. And that's using chain rules, and that's using both chain rules and trig identities. Okay. Next problem. Number 10, we have, let me make sure we did number 9 right. Yes, number 9 right. Okay. Number 10, we have product rule using trig. So first, let's take the derivative of this. Negative 3. We do not use chain rule because there is no f of g of x. It's just a simple function over here. So the derivative of that will be negative 9 x to the 2nd power. Derivative constant is 0. Times cosecant. Cosecant normal because derivative first and normal second. CSC of 5x fourth. Darn, I don't like how this app doesn't write the parentheses because sometimes it gets confusing where the parentheses go. So here's the parentheses, 5x fourth. Okay, then we add. Now we leave the first one the same, and then take the derivative of the second part. Cosecant, as we learned earlier, as we wrote down earlier, is negative cotan x. Okay, I'm out of room here, so let me rewrite this. Negative 3x cubed minus 1. Oh god, minus 1. Okay, and let me erase this. I'll leave the plus sign there. All right. Okay, so plus, we leave the first part the same. Now we take the derivative of the second part. Cosecant x, derivative of that is negative cotan x and cosecant x. So it will be times negative. So if we multiply this entire thing by negative, I just change this to a negative. There we go. Negative, and it will be cosecant x times tan x. Now it's not x because we're taking it with respect to g of x, which in this case is 5x fourth. So it'll be cosecant 5x fourth. That's a 4 up there, by the way. The pen keeps like 5x 4 up there, that's 4, times tangent of 5x fourth. Now we're not done yet because we got to use chain rule. So now we got to keep multiplying by the derivative of the inside, which is g of x, which is going to be 4 times 5, 20. 20 x to the 3rd power. Okay, let me check my work. Okay, down in there in the answer key, they should have done the exact same thing except put they evaluated the 20x times 9. Okay, what happened to the 20x? We're not gonna worry about it because I'm almost 100% sure my work is right. Okay. Number 11. Cosine 3x cubed. So same thing. Product rule. Cosine 3x cubed will be derivative of cosine. Oh my god! In fact, put the parentheses here. So cosine, derivative of cosine is negative sign, and now instead of with that, we write it with respect to g of x, which is 3x squared, times the derivative of 3x squared, which is 6x, plus. Okay, now we take the derivative. No, whoops, sorry. So that was the derivative of the first part. We use chain rule for the derivative of the first part. Now we multiply that by the normal of the second part, which is 5x cubed. That's a 5. 5x cubed minus 1 to the 1/3 power. Now we add by keeping the first. Now we keep the first part the same, 3x squared, times the derivative of the second part, which we use chain rule. So 1 over 3 times 5x cubed minus 1 to the negative 2/3 power. 1/3 minus 1, negative 2/3 power, multiplied by the derivative of the inside. So 5x cubed minus 1, derivative that will be 15x to the second power. Now there's no way I did any of that wrong. So let me check the answer keys. I'm not sure what the answer key did, but okay, cosine of 3x cubed times 1 over third x minus all that times 15x squared plus 5x cubed minus 1 to the 1/3 times negative sine 3x squared times 6x. Okay, great, perfect. This is my answer key. There we go. Okay, so number 12, sine of 4x cubed. Again, the parentheses. Make sure you always write the parentheses on your FRQs, or the teacher will be very confused and they won't like it. And if you have a mean teacher, they'll mark it wrong. So sine x. So our f of x is sine x with respect to g of x, which is 4x cubed. Derivative of sine x is cosine x. Cosine, instead of writing x, we write it with respect to g of x, which is 4x cubed, times the derivative of the inside now, which is just 12x squared. 12x squared. Okay. 12x squared cosine 4x cubed. Okay. Number 13, we have 4x plus 4. Okay, so we use quotient rule. Quotient rule will be derivative of the top, which is 16x to the third power times the normal of the bottom, 10 3x fifth, write your parentheses, minus the derivative, the normal of the top, 4x4 plus 5 times the derivative of the bottom. So derivative of the bottom, derivative of 10x is secant squared x. So we have secant squared of x, which are inside g of x is 3x cubed, 3x fifth. And then we take the derivative of 3x fifth, which will be 15x to the 4th power. Drop the 5 in front, 3 times 5, 15. 5 minus 1 on top, 4. Okay, so that's it. And then on the bottom, that's the top part. On the bottom, we have the bottom, which is 10x, 3x fifth to the square. That's it. The bottom is 3x fifth power squared. Okay. And then number 14, we have cotan. Let me rewrite this into a way that I like more, which is negative 5x cubed minus 2 to the 1/3 power. Okay, so we first factor out. First, we take the derivative of cotangent x with respect to everything. All this. The derivative of cotangent x is negative cosecant squared x. Instead of writing x, we write negative 5x cubed minus 2 to the 1/3 power. Okay, now we take the derivative of g of x, which is this. So to do this, we need to use chain rule and power rule. So power rule, we drop the 1/3 in front. 1/3 times negative 5x. Not in room again. So let's write the plus here. Plus, drop the 1/3. And then negative 5x, we keep the inside the same, because now, okay, this entire thing is g of x, but you can treat this entire thing like f of g of x once again and apply the same chain rule. So our f of x will be x, treat this entire thing as x to the 1/3 times, and then with respect, the x is with respect to g of x, which in this case, now your g of x would be this. So as you can see, you can do layers of chain rule, layers after layers, and all of it work the exact same way. We just do the cotangent part, treating this like a g of x, and after we're done with that, we do this part, treating 5x cubed minus 2 like g of x. Okay, now we drop the 1 front. Do we drop the 1/3? Okay, this is equal to. Make sure you write your equal sign, because I just got confused what is going on here. So this is negative. Okay, now we plus. This is no. I think this is chain rule. This is chain rule, so we multiply. So this is chain rule, so we multiply. Now we multiply by 1/3. Drop the 1/3 in front times. That's a 3. 1/3 times negative 5x cubed. Negative 5x cubed minus 2 to the negative 2/3 power. Okay, now we're not done. We still gotta multiply one more, and now we gotta multiply the derivative of this. So this will be our last step, which is be negative 15x squared. And that is our final derivative. Let me check the answer key. We have negative cosecant squared x to the negative times of negative 5x cubed minus 2 to the 1/3 power times 1/3 of negative 5x cubed minus 2 to the negative 2/3 power times negative 15x squared. And that is completely correct. So that is it. That is all of our practice problems with trigs and with derivatives of trigonometry and also using chain rule. I hope this video helped, and thank you for watching.